Hi everyone, this is Lady Manu coming with part 6 of translations of the quadratic parent function. Now, we ended part 5 on 7ab. That's what we did. Make sure you review that. Now, you're going to answer number 8, you're going to use the information from 7a and, 7a and b and 6a and b. You will be comparing g of x to h of x, okay? And make sure you read the information and compare it and respond to it. Make sure you write down your observation. Make sure you notate the vertices, the domain of range, the axis of symmetry, and continue the rest of that information on there. So I'm going to go to 13a. Here you will notice that it says complete the table for f of x equals x squared, and you know that this right here is the parent function. I mean, you already have the points in the data. You should be able to graph that. Just look at your other problems. So you know you're going to have that, and it's a little different because here you got x plus 3 all in parentheses raised to the second power. Okay, so now on the other ones, you didn't have that. Notice this is not in parentheses. That's x squared plus 3. The square is just on the x. It's not including the 3. So make sure you're very observant. So here for the parent function, we know that the y value for the parent functions are all positive. So we know this 9, 4, 1, 0, 1, 4, 9. We know that's the parent function. So now let's do the k of x for this formula, for this problem. Now keep in mind that on the others we could just do something to 9, but here it's different because it's an x plus 3 squared. So you're going to have to, and I'm going to use a pencil because I may make a mistake. Here my x value, I'm going to say negative 3 plus 3 squared. All I do is I'm substituting in the negative 3 for the x value. So negative 3 plus 3 is 0. 0 squared. What's 0 squared? 0. There you go. So I know this is 0. Then I'm going to do the same thing. I'm saying negative 2 plus 2 square it. Negative 2 plus 2 is, guess why I put a 2 there? I don't know. So what am I going to do? I'm going to erase it because this is supposed to be a 3. Okay. So negative 2 plus 3 is 1. And we have 1 squared, which is 1. Okay. Then we have negative 1 plus 3, all squared. Negative 1 plus 3 is, there you go, 2 squared. And that'll give you 4. Then 0 plus 3 squared. You know 0 plus 3 is 3. 3 squared is 9. Here we have 1 plus 3 squared. 1 plus 3 is, there you go, 4. 4 squared is 16. Here we have 2 plus 3, which is 5, and you square 5, you get 25. Here, 3 plus 3 is 6, and you 6 squared, you get 36. Okay, so you just fill in your table values. So you got 0, 1, 4, 9, 16, 25, 36. And you're like, wow, you're like, it's nothing repeating. But think about it like this. Here, our lowest is 0. Our lowest y value is 0 for k of x. What if I put negative 4 there? Just think about it. If I have negative 4 plus 3 here, and I square negative 4 plus 3 equals negative 1, and you square negative 1, you get 1. So it is repeating itself. Okay? So you have that information. So let's, here, I'm not graphing it. You have to graph it. It's a then graph both functions on the same coordinate grid. So here, on this grid-like part, you graph it like I did. You have the points or what have you. So you can go ahead and graph. Excuse that announcement. Excuse the announcement. I'm sorry about that. Still at school. Okay, you have the points in the table values to graph these, both of these functions. So you graph it and compare it. Here, what I'm going to do, I'm going to use the table to determine the vertex, the domain, and axis of symmetry. So when I'm looking at this information here, I'm like, okay, the vertex we know for the parent function, we know it's going to be 0, 0. We know the domain for both is all real numbers. because of it's quadratic, but I don't know if it's open upward. If this is positive, then it's open upward. But you need to check, because what if I'm wrong? What if that teacher is wrong? Okay. So I'm going to leave that alone. Here, I know that my range is going to be y is open upward because it's the parent function. It's greater than equals to 0, the y value of the vertex. The axis of symmetry is the x value of the vertex, so I know it's x equals 0. Okay. Look, the vertex really help you. And I know this vertex is a minimum because I know it's open upward. Okay. Now, here, the vertex, I can look and see where it started repeating in the table. Notice I had put this 1 here. I was like, if I go up to -4 for the x value, then I end up with a 1. It start repeating because of -4. When the x is -4, I get 1. When x is -2, I get 1. So here, -3, 0 must be my vertex. Okay, but you verify that. If this is true, then I know my range is going to be y something 0. If it's open upward, I know it's going to be greater than equals to. If it's open downward, if this is open downward, I know it's less than equals to. Okay, I know that my axis of symmetry is the x value of the vertex. So I know that's x equals -3. Okay, so it's information I can get from the table. But you are going to have to fill these two in once you graph it to see if it's open upward or downward. Okay, so you do that and you compare. And guys, that's going to be it for this. I think based on the information I've given you, you should be able to graph these table values and you should be able to go and do the rest of translation of the quadratic parent function, and you should do very well with it. Love you guys. Appreciate you. Bye-bye.